Let's do a few more examples of angular speed and linear speed. And I just copied my formulas up here. So this is linear speed is v equals the arc length over t. And remember that arc length is equal to the radius times the amount of angle that it is. So if we have an angle like this, we travel this arc. So we're basically saying what part of 2 pi is that, and then times the radius. Then for angular speed, which is a measure in the change of the angle, we have theta divided by time. So how much time does it take to go that angle? For example 4, the radius of each wheel of the car is 15 inches. If the wheels are turning at a rate of 3 revolutions per second, how fast is the car moving? And they ask us to answer in miles per hour. Note, though, that they give our information in inches per second, so we're going to have to do some conversions at the end of the problem. So we know that the radius of the car wheels is 15 inches, and a full revolution would be 2 pi, and it does 3 revolutions per second. So our V is going to be equal to 15 times 3 revolutions of 2 pi for every 1 second that we get. We put that into our calculator and we get 282.743, and this would be in inches per second. But we don't want inches per second, we want miles per hour. So we have to do a little bit of converting, and it's important that you know some conversion factors, which hopefully you already do. But you know that there are 12 inches in 1 foot. Hopefully you know that there are 5,280 feet in 1 mile. You also already know that there are 60 seconds in 1 minute, and that there are 60 minutes in 1 hour. So what we're going to do is we're going to set up our equation so that our units cancel out and we get the thing that we want by setting up various ratios. So we get 282.743, and this is inches per second. That's 1 second. So let's start by changing the inches. I'm going to put in a conversion factor that does inches to feet, which means I want inches to cancel out. So 12 inches is going to go on the bottom and 1 foot is going to go on the top. Now I'm going to put in a conversion factor from feet to miles. So feet are going to go on the bottom, 5,280 feet on the bottom and 1 mile on the top. And what you can see is that this inch unit will cancel this inch unit, this foot unit cancels this foot unit, and all that's left as a unit on the numerator is miles. Then for seconds, you could go ahead and jump to the fact that there are 3,600 seconds in an hour, but I usually do it bit by bit. So I'm going to change the seconds first. So I need 60 seconds over 1 minute. And why did I put the seconds on top? Because I need this second here to cancel out with this second here. And then 60 minutes and 1 hour. So when I put this into my calculator, the easiest thing to do is just to multiply by everything that's in the numerator. So we'd have 282.743 times 60 times 60, and then divide by everything in the denominator. So hit divided by 12 and then divided by 5,280. And if you do that, you should get 16.065, and this would be miles. And then just to prove it that it's hours, this minute cancels this minute, the seconds already canceled, and there's an hour. So miles per hour. And that would be how you convert it. All right, let's look at example 5. The windshield wiper of a car is 18 inches long. It takes a third of a revolution, 1 second, and we want to know how fast is the tip of the wiper moving. If we think about a windshield wiper, it probably starts over here, it goes up and then back, but that's going to be equal to 1 revolution. So V is equal to the radius times the angle that it covers over the time that it takes. In this case, a whole revolution would be 2 pi times 18, that's the radius, and that would take 3 seconds. We put that into our calculator and we get 37.7 inches per second. That might seem really fast, but if you think about a windshield wiper, the part on the outside here has to travel a lot farther than any part that's on the inside here. So the outside of the circle is moving faster, technically, than the inside of the circle. So that's probably a reasonable answer. 37.7 inches per second. All right, let's look at example 6. To approximate the speed of the current of a river, a circular paddle wheel with a radius of 4 feet is lowered into the water. If the current causes the wheel to rotate at a speed of 10 revolutions per minute, what is the speed of the current? So we know our radius is 4. We actually have our angular speed because we know it's doing 10 revolutions per minute, and 10 revolutions per minute would be 10 times, sorry about that, would be 10 times around the circle, which would be 2 pi. So we know that this is 2 pi times 10 for every minute. So when we use our formula, V is equal to the linear speed, our radius is 4, our theta is going to be 20 pi because that's how many times around it goes, and that's over the course of 1 minute. So we end up getting 80 pi feet per minute. That doesn't make a whole lot of sense. Obviously, we would use our calculator to find a decimal of that, but we want miles per hour, so we're going to use our conversion factors again. We know that there are 60 minutes in 1 hour, so we've now converted to hours. And we know that there are 5,280 feet in 1 mile, so we've now converted to miles. All right, so multiply across the top, 80 pi times 60, divide by 5,280 feet, and you should get 2.856 miles per hour.